ಬಟ್ಟೆ ಬಿಚ್ಚಿ ತಲೆ ಎಲ್ಲ
Yeah, good morning all. Yeah, there are 28 participants. Let's wait a few more minutes for others to join. And before everybody join, let me just recall what we had covered in the previous session. Okay, in the previous session, we were looking at how to find out the Z transform of the finite sequences, right? In finite sequences, you have seen what is right-sided sequence, what is left-sided sequence, what is double-sided sequence, right? Yeah, we have found out the Z transform for the right-sided as well as the left-sided. I'll be going through very fast. Again, I'll be covering this very fast. Okay, maybe double-sided is something that I had not covered. I'll be covering that, and after that we'll take infinite duration sequences. What we had seen in the earlier sessions was finite duration sequences. Okay, now once we go through this fast, then we'll be going with the infinite sequences. Yeah, there are 31 participants. I hope there will be more with I'm asked to take the print screen to see how many participants are joining. Let me wait some more time for that. Okay, I think I can select somebody to speak to. Anusha? Anusha there?
Yes, sir.
Yeah, Anusha, can you just tell me where we had stopped in the last class? I'm little confused because I'm taking it for TC also. Have any notes of that?
No, sir.
No, you forgotten what we had done.
No, sir.
Okay, even I. Anybody, if you can give me that in chatting, where I had stopped in the last class. Yeah. Now let's go with this. Okay, in the previous session, we had seen how to find out the region, the Z transform and region of convergence for these sequences. What are sequences? Sequences are also the discrete signals. Okay, I request everybody to note because I will be doing a lot of mathematical things today. Okay, so I request everybody to have a notebook and a pen. So keep on noting what we are discussing here. Fine. So these three are what we had discussed. And so here this is all, yeah, this is something that we discussed regarding the right-sided sequence. Let me do this. Okay, right-sided sequence we had seen, and for right-sided sequence it is right-sided because it is 0 here. Okay, and for this we found out the Z transform. Okay, which is this, and this and the ROC for this is the entire Z plane except Z equal to 0. And similarly, the ROC for the left side sequence. This is the left side sequence because 0 is here. So this is left sided. Fine. We found out this Z transform of this for this particular sequence. Okay. And for this, the ROC was the entire Z plane except Z equal to infinity. Okay. And the next we saw was the double-sided sequence. This is double-sided sequence because the zero is in between. It is neither here nor here. If it is here, if the zero is here, it is right-sided. If the zero is here, it is left-sided. But here we have left-sided as well as right-sided. That's why it is called as double-sided. Okay, and the ROC of this is the Z transform is found out to be this, and the ROC is the entire Z plane except Z equal to 0 and Z equal to infinity. Okay, today we shall see how would the Z transforms of the infinite duration signals look like. Okay, till now what we have seen is for finite durations. Okay, now we shall see how the Z transforms and ROC look for the infinite duration sequences. Fine. The infinite duration sequence that we're considering today is the positive time exponential. It's called as positive time exponential because u of n goes from 0 to infinity. So it is positive time. N is having 0 to infinity, all positive values, positive integers. That's what it's called as positive integer. And this is an exponential. That's what is called as positive time exponential. What is the range of this? Anybody? If you can understand, what is the range of this? The range of a of n would be range of u of n. What is range of u of n? U of n is 1 from 0 to infinity. Since the range of u of n is from 0 to infinity, the range of a of n is also from 0 to infinity. Okay. Now, for such a signal, we have to find out the Z transform. Now, understand this. The Z transform equation is this. Whichever sequence you consider, whether you consider a finite sequence or infinite sequence, we have to start from this particular equation. Okay. And after we substitute, we bring that here. Okay. After we bring a of n, u of n. Okay. U of n is substituted as 1 here because u of n is 1 from 0 to infinity. See, earlier it was from minus infinity to infinity. Now we have taken it from 0 to infinity because from 0 to infinity u of n is 1. So u of n is not there. That means it is substituted as 1 here. Okay, so x of n is a of n u of n, and u of n is 1 from 0 to infinity. That's why this is written. Okay, now what we can do, we can take this n out. Okay, here is the n power of n, here is the power of minus n. So bring this n out, and this is how this equation would look like. Right now, what is our intention always? Our intention is to make this infinite sequence to be in this particular form. Earlier, what was happening? We had considered the finite sequences. Okay, in finite sequences, we could have easily written, we could have easily expanded this summation. Okay, say it's 1 plus 2 plus 3 plus 4. You can easily expand that into 4 summations, summation of 4 samples. But here it is infinite samples. So when we are dealing with infinite samples, you need to bring this summation to a standard form. What is that standard form that we have to understand? See here, this is the standard form. Everybody make a note of this. This particular format is something that we'll be seeing from here on many a times. Okay, so you need to be really good with this particular, you have to remember this. Okay, so if you remember this standard form of summation, then you can solve this. Otherwise, no. In place of a, we have a z inverse here. Okay, so in place of a, we have a z inverse. So this is applicable only when a is less than 1. So a z inverse is less than 1. Let's not bother about it. Okay, so a is less than 1, a z inverse is also less than 1. So how we can write, if it is, if summation is going from 0 to infinity, okay, then we can write a power n as 1 by 1 minus a. So in that sense, how can this be written as, in place of a, you need to have a z inverse. So that's why that summation can be written as, let's see, x of z is 1 by 1 minus a z inverse. So which is given by z by z minus a. How it is z by z minus a written? Z inverse is there, right? So you bring that z inverse to the denominator. Take the LCM, so z minus a by z it would be. So it is z minus a is there, and it here another z is there. So take that z to the numerator. So this is what this z transform of x of z would become. Well, z transform x of z is. Okay, and this this z transform is for the, see, this signal. You have to remember this signal. Okay, so for this signal, what is this signal called as? It is called as positive time exponential. For positive time exponential, this is the Z transform. Okay, now we have to find the ROC. ROC is already given as Z greater than A. Okay, so let's understand that. See here, now we have to find the ROC of this. Every time, remember, in Z transforms, every time you find the Z transform of any sequence, okay, you have to find out the region of convergence. So how to find out the region of convergence, which they have already found out to be Z greater than A, is something to be seen now. Here, in the above equation, x of z would converge or be finite. When would this be a finite entity? Tell me, when would this be a finite entity? Why we are seeing that as finite? And what is ROC? Understand what is ROC. ROC is, I hope my audibility is right. Okay, yeah, that's doing good. Yeah, see here, for the above x of z, how to find ROC and when would this converge? Let's again just see how this what is this ROC? ROC is region of convergence, which says that it is the values of z which would make x of z as a finite entity. Which values of z would make it finite is what we need to find out, and that would make the ROC. So how to find out ROC? See, another thing that you should understand, everybody, is when you're finding the ROC, don't consider this equation. Don't consider the equation in terms of z. Consider the equation in terms of z inverse. See this? Okay, consider this equation in terms of z inverse. Don't consider this. So suppose if this has to be finite, because x of z has to be finite, right? So suppose if this entity has to be a finite entity, what needs to be done here? It should not be 1 by 0 is what we need to understand. It should not be 1 by 0. That means x of z, if it is 1 by 0, then x of z would be infinite. That should not happen because that will not add to the region of convergence. What will be the region of convergence? Region of convergence are those values of z which would make this finite. So we understand if this is 0, this will be infinite. So if this is not 0, this would be a finite entity. So if this is not 0, means here this particular entity should be greater than 0. So that means this magnitude of this should be greater than 0. If the magnitude of that is greater than 0, okay, see here, this AZ inverse can be taken on the other side. So it looks like 1 is greater than AZ inverse. If you take this onto the other side, where this becomes 1 greater than AZ inverse. So if you see it the other way, it is as good as saying AZ inverse is less than 1. Now you take this Z to the denominator. So it would become A by Z. So it would be A less than A less than Z, or you can say Z is greater than A. So this is equivalent to Z greater than A. Understand this? So that is what is the region of convergence. I'll explain this again. To find the region of convergence, we have to see for what values of z, x of z would be a finite entity. So for this to be finite, the magnitude of this denominator has to be greater than 0. So it is as good as saying AZ inverse is less than 1, because AZ inverse goes here, means it's 1 greater than AZ inverse. So in other ways, it's saying AZ inverse is less than 1. So take this Z inverse as 1 by Z. So it would be A by Z. So it's A less than Z or Z greater than A. This is how we have to find the ROC. Okay, so therefore ROC is Z greater than A. Now we need to sketch the ROC. Now, for when we are going to sketch the ROC, you have to understand the terminologies like zeros and poles. Very important understanding. Okay, that one needs to have when you're plotting the region of convergence. Okay, everybody concentrate, focused. Okay, now we had this equation. Where from this equation has come? This is the Z transform of positive time exponential. See here. See, this is the Z transform of positive time exponential we have found out. This is the Z transform. Keeping this Z transform, okay, keeping this Z transform, how can we plot the region of convergence? It needs to be seen. Now, Before seeing that, we should understand what are zeros and poles. What are zeros? Okay, zeros are values of z which would make x of z 0. See, the values of z which would make x of z 0 is called as 0. The values of z which would make x of z infinity are called as poles. See, if x of z becomes 0 for some values of z, they are called as zeros of x of z. If x of z becomes infinity for some values of z, they are called as poles. Once again, keep this as a reference. For some value of z, if x of z is becoming 0, then that value of z is called as 0 of x of z. If any value of z here would make x of z infinite, then that value of z would be called as poles of x of z. And how they are represented? See, zeros are represented by O and poles are represented by x. Fine. Now, how many such poles and how many such zeros are there needs to be understood in this particular x of z. Everybody concentrate here. Now, x of z is there, which is given by z minus a. In this, when do you think your x of z would be a 0? Okay, is it possible that x of z would be 0 for some value of z here? If this z in the denominator is 0, is this 0? No. If z in the numerator, if it is 0, is it x of z is 0? Yes. See here, if you make this numerator z equal to 0, x of z would be 0. How many such z's are there? There is just one such z which would make z equal to 0. X of z would be 0 on being 0. So if this z is equal to 0, then x of z is 0. So we can say that there is 1 0 which would make x of z 0. Where is that 1 0? That 1 0 is in the denominator. Okay. Is there any way out in which we can make this x of z infinity? Is there a value of z which would make this x of z infinity? Now, see here, if z is 0, this would become 0. If this z is a, what happens? See here, if this z is a, it becomes a minus a, so it becomes a by a minus a. What is a by a minus a? A by a minus a is what? A by 0. A by 0 is infinity, so the x of z would become infinity. That means we have a 0 here and we have a pole here. A 0 is here because this z on being 0 would make this 0, and this z on being a would make this infinity. So this is a pole, this is a 0. So this z equal to 0 is 0. This z equal to a is a pole. Okay. So how is that done here? See what this needs to need to be understood very clearly. See here, you see this square here. That square is your z plane. You don't consider all this. Okay, the square, what the dark place, what you're seeing, shaded one. So that shaded place is the z plane. In this z plane, okay, what you need to do is you need to consider the zeros and poles. Where is our 0? See, 1 0 is at z equal to 0. So this is z, real z. The x-axis is real z. The y-axis is imaginary z. Okay, so the z's, the poles and zeros that we have here are real ones, because this z equal to 0 is a 0. This z equal to a is a pole. Okay, so there is, and how is 0 represented? 0 is represented by O, and that O is at the origin because it is at z equal to 0. See, z equal to 0, x of z is 0, right? So that's a 0 then. So this is a 0. There is 1 0. How many poles are there? There is 1 pole. Here is a pole. Okay, so that is represented by x. Understand that? Now 0 is represented here, pole is represented. That means poles and zeros are marked. After poles and zeros are marked, okay, we need to see the region of convergence. Where is region of convergence? See here what it says. It very clearly says here, The region of convergence is Z greater than A. Magnitude Z greater than magnitude A. So what we are doing? So here this is A. What you need to do is with this radius, you can use your compass. Okay, with this radius, okay, draw a circle. Draw a circle, and what is it saying? The Z transform, the region of convergence is Z less than A. Z less than A means these are all A's. See here, all these are A's. So this is called as the boundary of ROC. This circle is called as boundary of ROC, and that boundary of ROC is having a radius A. Okay, this is a circle. This is the circle of radius A. So that is the circle of radius A is called as boundary of ROC, and the ROC is less than A. ROC is less than A. So that means this is also the whole of this circle. Okay, is ROC. That means outside the circle it is not ROC. Inside the circle it is ROC, because ROC is Z less than A. So for positive time exponential, x of z is z by z minus A. Okay, with ROC z less than A. Z less than A means z less than A. Why it's a circle? Understand why it is a circle z less than A? See here, Z is not, it is magnitude Z greater than magnitude A. Magnitude A means it can take any values, positive value, negative value, and positive, that negative value could be anything. So if it falls on, yeah, see, if it falls here, if it is A here, it is minus A here. If it is, if A is equal to say some value, so it is, if it is positive, it has to be negative also. So it is here. If it is here, it is here. If it is here, it is here. Okay. So likewise, since it is magnitude of A would give you the whole circle. So x of z is z by z minus A with ROC z less than A. Or we can say that this is a circle, right? This is a boundary of ROC. It's a circle, and your region of convergence is within the circle. It's not outside the circle, but it is within the circle. So ROC for a sequence would be, which is the positive time exponential, which is positive time exponential. For positive time exponential, okay, the ROC is always within the circle. Fine. So that is what we need to understand. I'll come again. You should understand what are zeros. You should understand what are poles. Once you understand zeros and poles, then only you'll be able to plot this particular region of convergence. Okay. So this is ROC of x of n, a bar n, u of n. A bar n, u of n is called as positive time exponential. For positive time exponential, x of z is z by z minus A, and region of convergence is less than A. That is within the circle whose radius is A. Circle with radius A. Okay, we need to draw, and region of convergence is less than A means, Z less than A means it's within the circle. So this is ROC. Understand that? Or what is it saying? Oh, Z greater than A. I'm very sorry. It's saying Z greater than A. So that means Z greater than A. Sorry. Z greater than A means beyond this, outside the circle. Very sorry. Very sorry. Okay. I should have written ROC here along with this. Every x of z needs to be accompanied with the ROC. Okay. And that ROC is Z greater than A. That's why it is outside the circle, not within the circle. Outside the circle with radius A. Okay, outside the circle with radius. How this radius A, how this circle is drawn? Okay, so there is a pole at z equal to A. There is a pole at z equal to A. With this as the radius, you plot this circle, and region of convergence says it is z greater than A. So z greater than A means this shaded part is ROC. So it is outside the circle whose radius is z greater than A for positive time exponential. So let's go on with another infinite duration, that is negative time exponential. How the negative time exponential looks like? See, the negative time exponential looks like this. What was positive time exponential? Positive time exponential was a power n u of n. You can, if you have noted down, just see that your positive time exponential is a power n into u of n. So what was the range of that? The range of the positive time exponential was 0 to infinity. Okay. So now, can you make out the range of this? There should be a minus here. The minus was not there with the positive time exponential. This is a negative time exponential. So it very clearly says that it is a negative time exponential. So this minus is taken here as well. This extends from where we are seeing this. Can you tell me where is the range of this negative time exponential? Okay. Okay, we have I have a plot for that. I'll be showing you that. If you have not understood, those you have understood, it's good. If you are able to understand what is this, you're good. So here, I'll just tell you what is u of n. U of n is 0 to infinity. What is u of minus n? U of minus n is from minus infinity to 0. What is u of minus n minus 1? U of minus n minus 1 is shifting u of minus n to the left by one position. Okay, so all that plot I have, I'll be showing you. Okay, again, you have to find your Z transforms. The same equation you will make use of. Same equation you will make use of. Then you will substitute that x of n in this place. Fine. After substitution, what happens? We have to see what is u of n minus 1, because depending on what is u of n minus 1, what is u of n minus 1, we can set the limits here, otherwise we'll not be able to. So what is u of n minus 1? There is something is given there, so let's understand that by looking into this. What is u of n? What is u of n here? Just a sec. I think my screen is paused. It is saying maybe it's a problem with the network. I'll try to do that. Resume share. Yeah. You see here. This is. See this. This is u of n. Your screen is shared. Your screen shared is paused. Please move this away from the shared application. Just a second. It is not allowing me to go to a link. Okay. So let's not bother. Let me go here. Fine. So understand u of n. Maybe I'll have to show that separately. Maybe just a sec. I'll do that. I'll stop this share, and maybe I'll go with this share. I hope you are able to see this. See here, u of n is there. U of n is from 0 to infinity. This dots means it is infinity. 0 to infinity, it is 1. U of minus 1, it is the reflection of this. Okay, it is going from 0 to infinity, means this will be going from minus infinity to 0. So u of minus n is minus infinity to 0. What is u of minus n minus 1? U of minus n minus 1 is shifting u of minus n to the left by one position. So it's shifted. Earlier it was from minus infinity to 0. Now it is from minus infinity to minus 1. I'll go again. Just observe. U of n is from 0 to infinity. U of minus n is from minus infinity to 0. I have last 1 minute, 10 minutes. Maybe I'll be able to finish up this problem within that. Just yeah, just understand that the u of minus n minus 1, okay, is a signal whose whose range is from minus infinity to minus 1. Its range is from minus infinity to minus 1. See here, n less than or equal to minus 1. So it is 1 from minus infinity to minus 1. Okay, so yeah, the range is from minus infinity to minus 1. Okay, see here, keep this as a reference. Now, the mathematical operation that we are doing on summation should be the purpose. What is the purpose of that? Is the purpose of bringing the standard summation. Okay, what is, okay, this is the equation we have now. Why did this equation come? Here, the equation is here. U of minus n minus 1 is minus infinity to minus, it is 1 from minus infinity to minus 1. That's why it is written as minus infinity to minus 1. U of minus n minus 1 is 1. So that is substituted as 1 and you will end up getting this. Now, what is the purpose here? The purpose is to get this particular standard summation in this form. Otherwise, you will not be able to solve the summation. Okay. So, how to get this standard summation? How to get this resultant summation in this standard form? If it is in this standard form, then only it will be able to be solved. Otherwise, it's not. So that's what we have to think of. Now, there is minus. We have to get rid of this minus. How to get rid of this minus here? If you multiply n by minus m, or just see this. Suppose we do this. What is that? What did we do? We brought this n out, so it is bz inverse to the power n. So this is n, this is minus n. So I took this n common, so it looks like b to the power 1. It looks like z to the power minus 1. So n is out. Now substitute n equal to minus m. Why it is being done? Why we are substituting n as minus m? Because I want to see positive things here. Positive, because here we have 0 to infinity, that's positive, right? But here it is negative. So to get this negative entities into positive, I'm substituting n as minus m. So when I do that, how does it look like? So this n now becomes m. So when you substitute n as minus m, so this minus would go and would become plus infinity, and this minus 1 would go and would become plus 1. But since this n is minus m, this n now looks like minus m. Understand? I'll come again. What we are trying to do is we are trying to express this particular summation in terms of this standard summation. Understand? So for that, what's happening? We are trying to get this minus, get rid of this minus. To get rid of this minus, what we are doing? We're substituting n as minus m. So minus infinity. So n has become minus m. Okay, so that means this minus infinity would become plus infinity, minus 1 would become plus 1. Since there is a n here, so that n would become minus n. Next, what needs to be done? There is positive power here, so there is negative power. How to get rid of this negative power? Make this as z, make this as z to the power 1, make this as b to the power minus 1. So it becomes, so just take this minus inside. Just take this minus inside. I want this to be n. I want this to be a positive power. So for that, you take this minus inside. So it would become z, and this b would become what? B inverse. Okay. So that is what is shown here. The b became b inverse and z became z. Z inverse became z. That's why this minus m and m has become m. So okay, this 0 we don't want it from 0 to infinity, but we have 1 to infinity, right? So how to make it 0 to infinity? Take this 1 to the left side, so make it m minus 1 equal to 1. Okay, now what happens if you do that? What we have done, just see here, this 1 is taken to the left hand side. Fine. I want a 0 here. Why I want 0? It is going from 0 to infinity. If it is going from 1 to infinity, no, I don't know what to do. So I want it from 0 to infinity. So for that purpose, okay, what they've done is they have taken this 1 to the left hand side. So it would become m minus 1 equal to 0. That is this, m minus 1 equal to 0. Now it is from 0 to infinity. Okay. We got it from 0 to infinity. This is positive 0. This is positive infinity. So this is positive, this is positive. We are able to get it, but this is m minus 1. Let's try get into one format. It is n, right? Let's not have n minus 1. Let's have just one variable. What is that? Let's take m minus 1 equal to k. Just to have, instead of saying m minus 1 equal to 0, say k is equal to 0. So for that to happen, what we can do? M minus 1 as k you can substitute. If you are substituting m minus 1 as k, for simplicity, what would happen? This m has to be substituted as k plus 1, because m is if you take 1 this side, so you do k plus 1. So if m minus 1 is k, if you're substituting this as k, this m has to be substituted as k plus 1. Okay. Now with this, what has got nothing to do within the summation? So k is running from 0 to infinity, right? So this particular entity, it is bz inverse z to the power k into bz inverse z to the power 1. So that you take out, okay, and just deal with this particular entity, this particular part of the summation, because when k is not there, that has got nothing to do within the summation. So keep that b inverse z out. So what is left behind if you take bz inverse out? Okay, you'll be left with bz inverse k. That's here. Understand that? So now this is in this standard form. This is in this standard form. Okay. So this is how it is going to look like. Now, since we know summation 0 to infinity a power 1 n is 1 by 1 minus, this can be written as bz inverse into this whole stuff is written as 1 by 1 minus b inverse z. Okay. So this b inverse z by 1 minus b inverse z it becomes, and if you work out, if you take this as z by b and this as z by b, this happens to be z by z minus b. So therefore x of z is z by z minus b. We have to find out the ROC also. For finding the ROC, what we need to do, don't take the entity where b inverse is not there. Take the equation where b inverse is that. You can take this. Okay. So for this, for x of z has to be finite. Okay. This has the magnitude of this has to be greater than a, as we have done in the previous case. Okay. And what happens if it is so? It becomes z less than b. So there in positive time exponential, it was z greater than a. Now here in negative time exponential, it is z less than b. Okay. So this is the x of z. This is the x of z, which is z by z minus b, but with ROC z less than b. So how does the ROC looks like? See, the ROC is within the circle. The ROC is within the circle. Now this is ROC. Earlier this was ROC. Now this is ROC. For negative time exponential, ROC is z less than b. Okay. For positive exponential, this is z greater than a. That's why the ROC is seen like this. Understand this? Okay. Uh, if you don't understand something, post some questions in Google Classroom. Okay, it's difficult to take the questions here because the time is not sufficient. Every time I want to take the things for uh, discussion, the time shows very less. Okay, it is, well, it is almost just a minute left. Okay, so it becomes difficult to take the questions for discussions. You post your questions in Google Classroom. May you make use of that. I still have not posted my assignment. Okay, most probably I'll be doing it after this class. Okay, you can see that and I'm sharing these slides also. Maybe you'll go through these slides. If you don't understand, you'll then post the questions. Okay, I hope the things are working out. Okay, if not, let's not give up. Let's keep focusing on it and let's learn. Fine. Okay then, if you have anything, okay, so contact me or communicate to me those doubts or questions, anything in Google Classroom. Fine. So let's stop this session here. Yeah.